right? So basically we started with the module number 2 and we have already covered 2 lectures on the module number 2. Okay, so basically I started with a static and dynamic analysis of a of this particular I started with a static and dynamic analysis, and then we understand the crank dynamic analysis of a slider crank mechanism, and then I have explained this force analysis diagram, right? So this is called the force analysis diagram of the IC engine mechanism. IC engine mechanism is what? Slider crank mechanism. Okay, and then this is a diagram which you have to remember, right? So basically uh, you may would have to draw this diagram in your particular exam. Okay, so FP is the piston effort, FN is nothing but a thrust piston effort, FQ is nothing but the force acting along the connecting rod, right? Then this FQ is, you can say, can be resolved into the two components. One is the FT, a tangential force, and second one is the FR, or you can call it as a FB also, FR or FB, you can call it. So it is nothing but a radial force, right? And then finally we have derived some formula for this. Okay, so we derived some formula for this, we went to the derivation. Okay, then we have understand some concepts, and finally we got FP, right? Then piston effort. Okay, crank pin effort FQ. Okay, so crank pin effort P, FT is equal to R. So all this formula which we have derived. Okay, so finally I got this formula for the T, that is FPR sine theta upon sine 2 theta into 2n. Okay, so till here we have seen the derivation. So I hope you have understand this. If still you have any doubt, you can watch the recorded lectures. Okay. Now next, very important concept. That is now today I will be explaining the two concepts. One is the equivalent dynamical system. Now basically, first of all, you have to understand what is equivalent dynamic systems. Okay. So for that, I will give you some figure in the front of you. Okay. I will display the figure. Right. So now basically what happens, first of all, what is this equivalent dynamical system, we'll understand. Okay, so many times let us say we have some rigid body. Okay, we have some rigid body, and basically what happens, many times it is convenient to represent this rigid body of a given mechanism. Means what, there is some mechanism, and in that mechanism, let us say you have a rigid body. Okay, so for simplifying the analysis, try to understand my point. For simplifying the analysis, right? For simplifying the analysis, okay, what we do, we represent this rigid body into a convenient equivalent dynamical system, right? We represent. See, I am repeating my statement. Uh, Many times it is convenient to represent a rigid body. This is a rigid body. So you have to represent this rigid body of any given mechanism by a dynamically equivalent system. Okay, why? Because it will simplify your analysis. I hope you understand this. Let me give you an example. Now let us say this is a rigid body, right? Now this is a rigid body. Now this rigid body, what we can say that, let us say that to do some analysis, we consider that the rigid body is having a mass n, right? This is nothing the center of gravity, right? And we can say that k is the radius of gyration of this rigid body, right? K is the radius. You understand what is radius of gyration? See what I am trying to do. Okay, I have considered a mechanism, right? I have considered any mechanism. Okay, you consider any mechanism. So in this case, basically, which mechanism you have considered? Anybody? In IC engine mechanism, you have. I will talk about the application first of all to make it simple. Which is the mechanism which we have studied in this particular topic or module? Anybody? Which is the particular mechanism?
Slider crank.
Slider mechanism. Okay. Now, can anybody tell me what is the mechanism? Which is the rigid body in this slider crank mechanism? Which is the rigid body in this slider crank mechanism? First of all, anybody? Connecting rod. Okay. So let us say this is a connecting rod. So I have taken let us say this connecting rod is a rigid body. Okay. Now this is how, first of all, you understand this is how connecting rod looks. Okay. This is a big end called as a big end of the connecting rod. This is called the small end of the connecting rod. Okay. Now this connecting rod, small end, is connected to the piston and piston pin right? And this big end is connected to the crank and crankshaft, right? So this is what I've already explained you. Now I'm just showing you, right? Let us say the distance between from this point to this point is L, that is the length to up to the CG, okay? So the radius of variation is K for this particular body. So this is nothing but a connecting rod, right? So let us say that this connecting rod I am considering for my analysis, okay? So let us say this rigid body is any connecting rod. It doesn't matter it is a connecting rod, but for this particular syllabus, I am considering as a connecting rod. So a rigid body having a mass m about the center of gravity, the radius of variation is k. Okay. Now basically, you cannot. What I mean to say, you cannot use this rigid body directly as it is. You cannot put forth this rigid body directly as it is into the mechanism. Okay, because you have to make this system stable. You have to make this system dynamically equivalent. And to make why? Because you have to make your system run stably. You have to make your system analysis very easy, right? So basically, what I will do, let us say that this equivalent dynamical system, so a rigid body is replaced. This mass m is replaced by two concentrated masses, right? This mass m is represented by or replaced by. The replace is the perfect word. I am replacing this by two masses, let us say m1 and let us say m2. Let us say this is the center of gravity of mass m. Center of gravity of mass m. So basically I mean to say is that this is nothing but your mass m, let us say. Okay, original mass. This is your original mass. This I am replacing with m1 and this I am replacing it with m2. Okay, and let us say that L1 is the distance from m1 and the center of gravity of mass m, and L2 is the distance from the center of gravity of mass m. Now basically it is very important that how you place these masses. So it is very important that you should know what is L1 and what is L2. So what I mean to say is that you cannot randomly select L1 and L2, right? You cannot randomly select L1 and L2. Okay, so you should have some derivation, you should have some specific relation. If you have some specific relation, and from that relation you can calculate this L1 and L2, and then I can replace this mass m, I can replace with m1 and m2. So what is that relation? And to find that relation, what are the conditions and what is equivalent dynamical system, that we have to understand. I hope it is clear to you now. Okay, let us move forward. Okay, so basically now this, I hope you have, first of all tell me, have you understood this diagram, what I am trying to do, so I can move forward for the analysis. Anybody? Have you understand what I am trying to do? What I have considered? I have considered a rigid body, let us say a connecting rod. Okay, it is having a mass m. I am replacing it with mass m1 and m2 at a distance L1 and L2. Now to do this, I should satisfy certain conditions. So what are that certain conditions which I should satisfy or you should satisfy? Let us see. Okay. So consider the rigid body having a center of gravity at G. Let m is the mass of the body. So m is the mass of this rigid body, right? Kg is the radius of gyration about its Cg. Let us say Kg is the radius of gyration of mass m Cg. Okay. Then m is the mass of the body. Let Kg is the radius of gyration about Cg. Okay. M1 and M2 are two masses which form a dynamical equivalent system. Means what? I am replacing this M1 by M1 and M2, right? I am replacing my mass as M1 and M2. In the connecting rod, which I showed you picture, there also you can see you have a two masses. Let us say M1 and M2. Now, if you have like two masses M1 and M2, you have to properly replace it so that it becomes a dynamical equivalent system. Now, what do you mean by dynamical equivalent system? That we have to understand first. Okay, so let us move forward. A two-mass dynamically equivalent system must satisfy the following three conditions. Means what? If you want to replace your mass m with m1 and m2, and this m1 and m2 are called as a two-mass dynamically equivalent system. They are called as a two-mass because I am replacing this mass m by two masses m1 and m2, and you will call it as two-mass as a dynamically equivalent system only when you will satisfy the three conditions. So guys, let's understand what are the three conditions. The first condition is that the sum of the two masses will be equal to the mass of the rigid body. Means what? M1 should be equal to M1 plus M2. M should be equal to M1 plus M2. Is it clear? Is it clear? The sum of the two masses must be equal to the mass of the rigid body. right? This is your first condition. Then and then only you can say that the system, you can replace the masses m into m2. Next, the center of gravity of two masses must coincide with that of the rigid body. Let us say G is the center of gravity of mass m, G1 is center of gravity of mass m2 and m1, and G2 is the center of gravity of mass m2. Okay, so this condition is what? The center of gravity of the two masses must coincide with that of rigid body. Means what? Your ml1 should be equal to ml2, right? This is possible when ratio of m1 upon m2 is equal to l2 upon l1, okay, or vice versa, that is m1 l1 is equal to m2 l2. Guys, it is clear? It is clear or not? These two conditions, okay. Now the moment of inertia of the two masses must be equal to the moment of inertia of the rigid body. Let us say that Ig is the moment of inertia of a rigid body, Ig2 and Ig1 are the moment of inertia of the two masses. Okay, so what is Ig1 now? What is I? I is nothing but the ml square. Okay, so m1 l1 square. Now you know that na I. Okay, I for this particular body is nothing but the ml square. Okay, that is a mass moment of inertia of a body, which is a mass moment of inertia of a body having mass m and length l. The I is nothing but the ml square. So this is already we have studied in the strength of material, right? So I am getting Ig is equal to Ig1 plus Ig2. That is, let us say Ig, the mass. Now you know that the mass moment of inertia of a rigid body is nothing but the mk square. Okay, I is equal to mk square, right? So I have considered this as a Ig1 plus Ig2 is equal to m1 l1 square plus m2 l2 square is equal to m3 l square. Okay, so if you are able to satisfy these three conditions, then the system is called as a dynamically equivalent system. Okay, and if if you are able to satisfy only the two conditions, let us say condition number 1 and condition number 2 is satisfied, then the system is called as a statistically it is called as a statistically statically equivalent system. Statically equivalent system. And if the three conditions are satisfied, it is called the dynamical equivalent system, right? So basically now guys we have understand what is statical equivalent system and what is dynamical equivalent system. I have explained in the first lecture. So if you are able to satisfy these two conditions, it is called the statically equivalent system, and if you are able to satisfy all the three conditions, it is called the dynamical equivalent system. So somebody ask you what are the conditions for a system to be statically equivalent and what are the conditions for the system to be dynamically equivalent, you can explain these three conditions. Now message me, have you understand these three conditions so I can move forward and derive the relation? Yes, anybody? Message, have you understand all the three conditions? I hope it is clear. And it's not so difficult, okay? So as I earlier said that if above three conditions, only first two conditions are satisfied, it is called as a 2-point mass statical equivalent system. Why I am considering a 2-point? Because I am replacing the m into the two masses, m1 and m2. And if all the three conditions are satisfied, then the system is called as a 2-point mass dynamically equivalent system. Okay. Now let us go to the derivation. Now let us say that the substituting the value of m2 from equation 2 in equation 1. Okay, what is equation 1? I will write here. Equation 1 is m1 plus m2 is equal to m. This is your equation number 1, right? What is the equation number 2? Equation number 2 is nothing but the m1 l1 is equal to m2 l2. This is equation number 2. Okay, so first of all, what we'll do? We'll substitute the value of m2 from equation 2. Now from equation 2, what will be the value of m2? Value of m2 will be the m2 is equal to m1 l1 upon l2, right? m2 is equal to m1 l1 upon m2. So put this m2 in equation number 1. कुठे टाकायचं आहे इक्वेशन नंबर 1 मध्ये पुट करायचं. मग पुट केल्यानंतर बघा तुम्हाला काय मिळणार आहे. You will get m1 plus m1 l1 upon 2. This is nothing but the what m2. Okay, is equal to m, right? So basically cross multiply or multiply both sides by l2. What we will get? You will get m1 l1 plus l2 is equal to m l2, right? Means let us say if you means see how I have got this m1 into l2 plus m1 l1 is equal to m into l2. Okay, so from this you can remove m common and you will get this equation m1 l1 plus m2 is equal to m2. So most of the time this derivation you will find in the exam. So I am trying to explain in the deep. Is it clear? Now next, From this, what you will get? You will get the value of m1. So m1 is equal to ml2 upon l1 plus l2. Okay, m1 is equal to ml2 upon l1 plus m2. We have got this. Okay. Now similarly, now let us consider equation number 1 and 2. Now from this, what you have got? M2. Now let us, what will be the value of M1? How will you find M1? So M1 is equal to M2 L2 upon L1, right? And put this M1 in this equation. So basically, guys, what I have to do? I have to put M1 once and M2 once, and then you have to find out the relation between the two. Is it clear? Okay. So similarly, what I will get? What I will get? Similarly, what I will get? I will get M2 is equal to ML1 upon L1 plus L2. You can see that this denominator is common in both the cases. Is it okay? Is it okay or not? What I have seen, right? So now equation number 3. Now what is equation number 3? Equation number 3 is M1 L1 square plus M2 L2 square is equal to MK square, right? Now we know what is M1. Now we know what is M2. Put this in equation number 3. Put in 3 m1 and m2. What is m2? m1 l1 plus l1 upon l2. And what is m1? What is l1? ml2 upon l1 plus m2. Okay, so you have to put this into this equation. So what I will get? Let's see what I will get. Anybody? Okay, so see, I have put this into the equation. Which equation? m1 l1 square plus m2 l2 square is equal to mk square. This is my equation number 3. Okay, so m1 I have put m2 l2 upon l1 plus m2. m2 I have put m1 l1 plus l1 plus l2. Okay, is equal to mk square. Okay, now what you will get? What you will get the final relation? So this m and m will get cancelled, right? M will get cancelled, and finally you are getting this L1 plus L2, this L1 plus L2 and this L1 plus L2 will get cancelled, right? And finally, what answer you will get? You will get K square is equal to L1 plus L2. So this is your final relation. This is your final relation. Okay. Now, if from this relation K square is equal to L1 plus L2, if this relation is satisfied, okay, you can say that the system is dynamically equivalent. You can say that the system is dynamically equation. Means what? So basically what you know, see, if the distance of one of the masses, that is either L1 or L2, is selected arbitrarily, then other distance can be obtained from the above equation. So what does this mean? What does this mean? Let me move backward now. Okay, let me move backward and help you understand. Now, okay, now let us say I have this rigid body, and I have to replace the rigid body into the two masses m1 and m2 such that the system is equivalently dynamically system. When the system is equivalently dynamical system, when it will satisfy all the three conditions. So what you will do? Select L1 randomly. Select L1 randomly. Then use the relation k square is equal to, what is the relation? K square is equal to L1 plus L2. Now, if you select, even if you select L1 randomly, and if you put the value of L1 from this equation, you will get the value of L2. Okay, so then you will get a value of L1 and L2, and then you can replace M1 and M2 from the center of gravity of this mass n. Okay, and you can say that the system is dynamically equivalent. Now tell me, have you understand this or not? Have you understand this? Have you understand how so this is the important equation, K square is equal to L1 into L2 for a system to be dynamically equivalent system. You have to solve the problems on this. Guys, tell me, have you understand this or not? Anybody who still haven't understand this equation? So I can move to the, but there is one more modification in this equation. This equation is not over yet. This equation is not over yet. Okay. What is the modification that I would like to explain? But till now, as usual, I have found out this equation k squared is equal to L1 plus L2. I know what is k. What is k? Radius of direction of this rigid body, right? So select L1 arbitrarily, you will get L2, and then replace this rigid body by this two mass equivalent system, such that this system is dynamically equivalent because it satisfies all the three conditions. Okay, but now let's move to the certain modification condition. Now let us take an example of a connecting rod. Okay, Now I have got a formula. I have got a relation k squared is equal to L1 and L2. If the system is able to satisfy this equation k squared is equal to L1 into L2, then you can say that the system is dynamically equivalent system. Now let us take an example. Now let us take an example and see what is the modification. Let us say the example is of a connecting rod, small end which is connected to the piston, big end which is connected to the crank, and small end is connected to the pin. Okay. Let us say that the distance between this point, let us say this point is O1. So distance between the point O1 and CG is nothing but the L. Right? So let us take an example. Now, basically, there is a concept called as a correction couple. Okay, there is a concept called as a correction couple. Now, what is correction couple? Okay, now basically, how first of all to understand the correction couple, tell me how many conditions you have understand. Tell me what are the conditions for a system to be dynamically equivalent. What are the three conditions? Anybody? What are the three conditions for a system to be dynamically equivalent? I just not we have derived. Let me write
M1
it.
plus M2 equal to M.
1 plus M2 is equal to N. Next is M1 L1 plus M2, sorry, M1 L1 is equal to M2 L2. Is it correct? Is it
Yes,
correct?
sir.
And what is third condition? M1 L1 square plus M2 L2 square is equal to MK square. Okay. Now this is the three condition. Now tell me for the system to be statically equivalent, how many which two conditions should be satisfied? For a system to
First
be
two.
statically equivalent, which two conditions should be satisfied?
First two conditions.
Which? Anybody?
First
Which
two.
two conditions we have to satisfy
First
for
two
the
First
system?
two.
conditions.
First two.
First two. Yeah, the first two conditions gives you statically. Okay, and for a dynamically equivalent system, for a dynamically equivalent system.
All three conditions.
Okay. Now let us take a practical case. So basically, in a practical case, let us say take an example of a connecting rod. So we are doing a force analysis of the IC engine mechanism, that is a slider type mechanism. So I've taken an example of a connecting rod. So in practical, in let us say in connecting rod, okay, connecting rod, what happens exactly? The first two conditions, that is a condition number one and condition number two, are easily satisfied. Are easily satisfied, but it is very very difficult to satisfy the third condition. It is very very difficult to satisfy the third condition. Okay, basically what happens, I will try to explain. What is my point of understanding over here? That in I have to satisfy all the three conditions, but in practical case, for example, connecting rod. In case of the connecting rod, which what is the mechanism? Slider crank mechanism. Okay, and in slider crank mechanism, basically we have to select M1 and M2 arbitrarily. Okay, we have to select M1 and M2 arbitrarily. Okay, we have to select M1 and M2 arbitrarily, right? Now, in that case, whenever you're selecting M1 and M2 arbitrarily, in a practical case, these first two conditions normally get satisfied, but this third condition is not easily satisfied, right? I will repeat again. I have to satisfy all the three conditions, but in practical case, most of the time, for example, if I take a slider tank mechanism, if I have to select basically M1 and M2 arbitrarily. Okay, because I know what is M. I know what is M. M is what the mass of the rigid body, let us say connecting rod. Now I have a two masses at the small end and the big end. Okay, so I don't know exactly what is M and what is M1 and what is M2. So I'm selecting M1 and M2 arbitrarily, right?
Yes.
Now, where I am placing M1, where I am placing M1, मी M1 कुठे place करतो? Where my mass M1 of a connecting rod. See, now I will move backward. See, let us say this is a mass M of this rigid body. Now this is let us say M1. I am placing M1 at the piston pin. I am placing M1 at the piston pin, and I am placing M2 at where? M2 at crank pin. Okay, to be more precise, in IC you will understand, but to be more precise, this mass M2 is placed at the crank pin and this mass M1 is placed at the piston pin. Okay. Now, whenever we are doing the analysis of this connecting rod, okay, I have to arbitrarily select M1 and M2 because I don't know exactly how much M1 I should take and how much M2 I should take. Okay, so in that case, what happens? Your first two conditions normally get satisfied, but the third condition is unsatisfied. And if the third condition is unsatisfied, the system will not become dynamically equivalent system. So there will be the you can say the vibrations inside the system. The system may fail earlier. The system may develop stresses. So a lot of conditions are there which we have already discussed. Okay. So basically, can anybody tell me what will happen finally? What will happen finally?
सर M1 M2 arbitrarily कैसे देते
Hello, hello. What I am trying to say, I am trying to say that the third condition is not satisfied. Third condition is not satisfied means what will happen exactly in this case? See, m is the mass of this let us say rigid body. M1 is the mass placed at the piston pin. M2 is the mass at the crank pin. I am selecting M1 and M2 arbitrarily. Okay. Because of that, my third condition is not satisfying. Means what? Your third condition is not satisfied means what? That the mass moment of inertia of masses m1 and m2 will be different from that of mass m. Na? Is it correct? The mass moment of inertia of m1 and m2, which are placed at piston pin and crank pin, will differ from the mass moment of inertia of this rigid body, that is a m, and that is not desirable. Means what? The system will not become dynamically equivalent system. So that is why basically what we do in the practical case, we apply the correction couple. What is that correction couple? That correction couple is nothing but the torque which is denoted by Tc. So this Tc is nothing but the correction couple which we have to apply. Now, what is this first of all correction couple? Try to understand. Before I derive, try to understand. This correction couple Tc is nothing but the difference between the T1 minus T2. What is T1? T1 is nothing but the torque required. T1 is nothing but the torque required to accelerate a non-dynamically equivalent system. Let us say, basically guys, first of all understand, let us say, let me take an example. Okay, let me take this is an example of a connecting rod. Okay, now this connecting rod has a mass m. Here is a m1, there is a m2. Okay, now let us say you convert this connecting rod into the dynamically equivalent two mass system. So what is the condition to satisfy this? What is the condition to satisfy this? K squared is equal to L1 into L2. So let us say this is a L1 and let us say this is a L2. Okay, now this system is called as a dynamically equal two mass system. Okay, now let me consider one more system which is a non-dynamically equivalent system. Non-dynamically equivalent system is what? This system does not satisfy all the three conditions, and this system satisfies all the three conditions. Now guys, you might get confused that why I am considering non-dynamically equivalent system, because I have to calculate a correction couple. And unless and until you consider a non-dynamically equivalent system, you cannot calculate a correction couple, because correction couple is nothing but the difference. Let us say the torque. Let us say the correction couple is the Tc torque, and the torque required to accelerate this non-dynamically equivalent system is T1. I am repeating my words. The torque required to accelerate. Accelerate means what? There are reciprocating components, so you have to apply some acceleration. So that reciprocating components, so masses will get accelerated, and because of it the inertia forces are generated. So let us say in non-dynamically equivalent system, the torque required to accelerate the system is T1, and let us say the torque required to accelerate the dynamically equivalent system is T. Okay, so this correction couple is nothing but the difference between the T1 minus T2. मग ह्या दोघांमधला जो डिफरन्स असेल तो म्हणजे तुमचा करेक्शन कपल असेल. And that correction couple we are applying on externally on that system, and then the system will become a dynamically equivalent system. हे सगळ्याच केसमध्ये करावं लागतं असं नाहीये, हे काही प्रॅक्टिकल केस करावं मध्ये लागतं. फॉर एक्झाम्पल इन स्लाइडर टँक मेकॅनिझम, बिकॉज इन स्लाइडर टँक मेकॅनिझम इन केस ऑफ द कनेक्टिंग रॉड I am selecting M1 and M2 arbitrarily. I hope you understand this. Okay, so that is why I have to do this. Okay, so let us say that this is a connecting rod having a mass m, m1 and m2. Let us say this connecting rod is distributed or replaced by the two systems. One is a dynamically equivalent system and one is a two mass non-dynamically equivalent system. Clear? Now tell me it is clear or not. I have to derive. मी ते derive करणार आहे तो फॉर्म्युला, पण त्याच्यासाठी तुम्हाला कन्सेप्ट कळली का? करेक्शन कपल आणि डायनॅमिकली इक्विव्हॅलेंट सिस्टीम. मेसेज मी येस और नो. Anybody, so I can move forward. Okay, so chalo. So now we'll start with the derivation. So to start with the derivation, let us say that consider this diagram, a diagram where I am showing by the arrow. So consider two masses m1 and m2 which are placed at point A and placed at point B respectively at a distance L1 and L2 from the center of gravity of mass mcg. Okay, such that this system satisfy all the three conditions. This system will satisfy all the three conditions. So it is called the dynamically equivalent system. Okay, आता मला या सिस्टीमला डिस्टर्ब करायचं आहे. आता ही डायनामिकल इक्विव्हॅलेंट सिस्टीम आहे ना, ही सॅटिस्फाय होती. ही सॅटिस्फाय कधी झाली? जेव्हा याचा k2 इज इक्वल टू L1 प्लस L2 होतं. ही सॅटिस्फाय झाली फॉर एक्झाम्पल. मग डायनामिकली इक्विव्हॅलेंट सिस्टीम सॅटिस्फाय झाल्यानंतर आता जर या सिस्टीमला मला डिस्टर्ब करायचं असेल, सो व्हॉट आय हॅव टू चेंज? टेल मी व्हॉट यू विल डू इफ यू वॉन्ट टू डिस्टर्ब दिस डायनामिकल इक्विव्हॅलेंट सिस्टीम. तुम्ही थोडक्यात काय चेंज करणार? कंडिशन काय? kx2 इज इक्वल टू L1 प्लस L2. मला सांगा, जर तुम्ही याचा L1 आर्बिटरली चेंज केला, म्हणजे लेटेस्ट जर तुम्ही याचा L2 चेंज केला, ती सिस्टीम बॅलन्स होती ती अनबॅलन्स होणार की नाही? म्हणजे सिस्टीम जी आधी डायनामिकली इक्विव्हॅलेंट होती ती डिस्टर्ब होणार की नाही? मला सांगा, इफ आय चेंज द L2, राईट? सिस्टीम तुमची डिस्टर्ब होणार की नाही? येस और नो? इफ आय चेंज द L2 इनिशियली
Yes, sir.
बेसिकली मग मी तेच विचारतो तुम्हाला ना, मला डेरिव्हेशन करताना काय करायचंय? मला ही सिस्टीम डिस्टर्ब करावी लागणार आहे का? तर मला डिफरन्स कॅल्क्युलेट करायचा आहे. सो लेट अस से दॅट आय एम चेंजिंग L2. सो नाउ लेट अस से दॅट I am adding the mass m2 at a distance d, at a point d, at a distance L3. So L3 is my third distance. So now you can say that this system is disturbed and the system is a two mass system, non-dynamically equivalent system, because now I have placed this mass m2 at a point d at a distance L3. Okay, is it clear? Now let us move to derivation. So let us say that I is the mass moment of inertia of connecting rod and dynamically equivalent system. I is the mass moment of inertia of a connecting rod and dynamically equivalent system. म्हणजे कुठल्या सिस्टीमचं? पहिल्या सिस्टीमचं जी डायनामिकली इक्विव्हॅलेंट होती. K is the radius of gyration of connecting rod and dynamically equivalent system. Right? Next, I1 is the new mass moment of inertia of a non-dynamically equivalent system. म्हणजे जी सिस्टीम तुम्ही आता डिस्टर्ब केली. कशी डिस्टर्ब केली? तुम्ही मास m2 ला D या पॉइंटला आणलाय, L3 या डिस्टन्सला बदलणं G या पॉइंट पासून. ही सिस्टीम डिस्टर्ब झाली. सो लेट अस से I1 is the new mass moment of inertia of non-dynamically equivalent system. K1 is the new radius of gyration of non-dynamically equivalent system. Is it clear? हे सगळं मला नवीन मिळणार. Alpha is the angular acceleration of a connecting rod. You know that you are applying some velocity, angular velocity. So angular acceleration will be generated. So inertia forces will be also generated because this system is a dynamic system. Na? So let us say alpha is the angular acceleration of the connecting rod. Okay. Let us say L1 is the distance of mass m1 over cg when placed at point A, distance of mass m2 from cg when placed at point, and L3 is the distance of mass m2 from cg when placed at a point D instead of P. Okay. म्हणजे cg पासून L1, L2, L3 आपण तीन डिस्टन्स घेतले. ती करेक्शन कपल कॅल्क्युलेट करतो. ओके. नाउ टेल मी the torque required to accelerate the connecting rod or dynamically equivalent system. आता तुमची डायनामिकली इक्विव्हॅलेंट सिस्टीम आहे. त्या सिस्टीमवरती तुम्हाला काहीतरी टॉर्क अप्लाय करावं लागेल ना. टॉर्क अप्लाय केल्याशिवाय तुमची ती सिस्टीम काय म्हणतो आपण, सिस्टीम एक्सेलरेट होणार आहे का? त्याचे रेसिप्रोकेटिंग मासेस रेसिप्रोकेट व्हायला चालू होणार का? नाही. बरोबर. मग त्याचा टॉर्क किती असतो? T is equal to I into alpha. हे आपल्याला ऑलरेडी माहिती आहे. ओके. सो व्हॉट इज I? I is nothing but a mk square because k is the radius of gyration. What is I? Mass moment of inertia of the dynamical system. So I got one equation. T is equal to mk square into alpha. So what is T? Torque required to accelerate the connecting rod or dynamical equivalent system is. Okay, is it clear? Now next, torque required to accelerate the non-dynamical equivalent system. आता non-dynamical equivalent system चा torque काय असणार आहे? T1 is equal to I1 into alpha. What is I1? M is constant, obviously. So T1 is equal to M into K1 square alpha. So I have got these two equations, equation number 1 and 2. Guys, it is clear? इथपर्यंत क्लिअर झालं का? मला मेसेज करा, yes or no. This is the last theory which I am explaining. ह्याच्यानंतर मग आपल्याला फक्त 2 लेक्चर मध्ये प्रॉब्लेम्सच बघायचे, सॉल्व्ह करायचे. ओके. I have last derivation. Have you understand this? T and T1. What is T and what is T1? Have you understand? Torque equal to accelerate non-dynamically system and dynamical system is nothing but a T1 and T1. Okay. Now, What is correction couple? मी तुम्हाला correction couple चं definition काय सांगितलंय? The correction couple is the difference between the torque required to accelerate non-dynamically equivalent system and torque required to accelerate a dynamically equivalent system. म्हणजेच काय? TC is equal to T1 minus T. बरोबर? TC is equal to T1 minus T. आता मला सांगा, आपण इथे सॉल्व्ह करूया आता पुढे. What is T1? Anybody? What is T1? कोणी सांगू शकेल मला T1 काय? Anybody? What is T1? आत्ताच आपण बघितलं ना T1 काय? M into K1 स्क्वेअर अल्फा, बरोबर ना? असंच आहे ना? M into K1 स्क्वेअर अल्फा, बरोबर ना? मायनस what is T? M into K square alpha. Because what is I? What is I? I is nothing but MK square. Right? So मला हे इक्वेशन मिळालं. बघा, पाहिजे जर नसेल समजा मी मागे जातो. बघा, T is equal to I into alpha. What is I? I is nothing but MK square. T1 is equal to I1 into alpha. I is equal to MK1 square. हे मी इथे घेतलं. ओके. सो नाव याच्यात मला कॉन्स्टंट काय मिळेल? कॉन्स्टंट काय मिळेल? TC is equal to M into what I will get? K1 square minus K square into alpha. Okay. Let me call this as equation number 1. Let me call this as equation number 2. Now, let me move to the back side, to the main diagram. Okay. Now tell me, for this equation, what is the condition of dynamical equivalent system? जर तुम्हाला आता ही ऑलरेडी डायनॅमिकल इक्विव्हॅलेंट सिस्टीम आहे असं माझं म्हणणं आहे, बरोबर ना? मग कुठलं रिलेशन सॅटिस्फाय झालं पाहिजे जर ही डायनॅमिक इक्विव्हॅलेंट सिस्टीम असली पाहिजे? एनीबडी? व्हॉट विल बी द रिलेशन?
K square is
equal to L1 into L2. तसंच आता ही जी नॉन डायनॅमिकली इक्विव्हॅलेंट सिस्टीम आहे, जर हिला तुम्हाला डायनॅमिकली इक्विव्हॅलेंट सिस्टीम बनवायचं असेल तर इथे कुठली सिस्टीम सॅटिस्फाय झाली पाहिजे? इथे कुठली कंडिशन झाली? हा, बोला, कुठली सिस्टीम झाली पाहिजे? व्हॉट इज द रिलेशन ओव्हर हियर फॉर दिस सिस्टीम टू बिकम अ डायनॅमिकली इक्विव्हॅलेंट सिस्टीम? अरे काय येईल? साधी गोष्ट ना. K square
is equal to L1 into L3.
त्याचं रेडियस ऑफ गायरेशन किती आहे? त्या नवीन सिस्टीमचं रेडियस ऑफ गायरेशन किती आहे? आपण काय कन्सिडर केलंय? K1 ना. So what will be K1 square is equal to what? L1 into
L3.
अरे हेच तर तुम्हाला कळलं पाहिजे ना. बघा, नोटेशन जरी चेंज झाले तरी कंडिशन चेंज होणार नाहीये. सो K square is equal to L1 into L2. So this will be the condition. आता मला इथे पुट करायचं फक्त हे मी इथे पुट करतो. इथे मी पुट करतो. सो TC is equal to मला काय मिळणार? फायनल इक्वेशन मिळणार M into what is K1 square? K1 square काय आपण टाकलं? L1 L3, बरोबर, मायनस आणि K square आपण काय टाकलं? K1 L2 आणि मला काय मिळालं? अल्फा. सो मला फायनल इक्वेशन मिळालं TC is equal to, त्यातून मी काय कॉमन काढू शकतो का? काही कॉमन काढू शकतो? M L1 कॉमन काढू शकतो, L3 minus L2 into alpha. So this is called as a correction couple and this you have to remember. Okay. So this is called as a formula for the correction couple. तर this correction couple, आता हे जे तुम्ही correction couple कॅल्क्युलेट केलंय, मी मागे जातो. काय कॅल्क्युलेट केलं correction couple? TC is equal to M into L1 L3 minus L1 L2, right? M into L1 L3 minus L1 L2 into alpha, right? So this is nothing but a correction couple. This is nothing but a formula for the correction couple. आता हे तुम्हाला कुठे अप्लाय करायचंय? This is nothing but a correction couple which must be applied. Which must be applied. हे कधी अप्लाय करणार तुम्ही? कधी अप्लाय करणार करेक्शन कपल? बघा तुम्हाला कळलंय का? दिस इज द, हे करेक्शन कपल पर्यंत मी का काढलं हे मी सुरुवातीला सांगितलंय. कधी अप्लाय करणार तुम्ही? किंवा कुठे अप्लाय करणार तुम्ही? हे करेक्शन कपल कधी अप्लाय करणार? दिस करेक्शन कपल, बघा नसेल कळलं तर लिहितो डायलॉग, मस्ट बी अप्लाइड. Must be applied when masses M1 and M2 are selected. हे सांगितलं तुम्हाला, are selected काय? Randomly किंवा arbitrarily. हे लक्षात ठेवा. ओके. हे करेक्शन केबल तेव्हाच अप्लाय करायचे when for in a practical case, for example in a connecting rod. Okay. So let me move backward. So let us say this is an example of a connecting rod. Okay, so this is an example of a connecting rod. In case of the connecting rod, when I am selecting M1 and M2 arbitrarily, for a system to become a dynamically clean system, all the three conditions are not satisfied. So in that case, when you are selecting M1 and M2 arbitrarily, in the practical case, basically in the slider tank mechanism, you have to apply the correction coupled TC. Okay, आता